So good morning, good evening, good afternoon, and welcome. All right, so today we're talking about vertex form of a quadratic. So this is the second half of lesson 9.5, where we needed to convert quadratic formulas into what's called a vertex form. A vertex form is kind of a unique form of an equation. And what it is the equation is set up so that way we can understand by looking at it some very important key factors. When we do I plan on doing a project in the springtime, we'll be using a lot of the vertex form of the quadratic, and we'll be doing a lot of relational aspects in terms of creating these equations. So this is what our main focus is. And in this value, what we're looking for is trying to understand and identify mainly what the h value is and what the k value is. And the h value is this part right here, okay? H is just a value in the equation, and the k value. And what it does is that you can interpret this equation. So for all of my students, the one big thing I want to make sure when you take away from Algebra 1 at the end of this year is that you can look at a graph. Doesn't matter what the graph looks like, and that you can interpret what the graph is supposed to be in terms of, is it linear, exponential, quadratic? And then you could actually draw out the graph, and you could actually give me the equation for the graph. Okay, so today's focus is starting on this. These notes were given in class. If you don't have them, please pick them up from me. Here's a key couple things. How you want to find these is this is kind of a shortcut on how to do it. The teachers teach it multiple different ways here. I'm going to go with Mr. Olson's method because I believe it's a little bit safer, or in terms of, not safer, but it's a little bit kind of user-friendly. But there's a trick to it that I actually made a mistake in class, and I had to kind of reteach it. So first and foremost is vertex. So our vertex form is find the vertex of the given quadrants, state whether it's a minimum or a maximum. So by looking at this, you want to see if this value, so it's a, which doesn't really matter too much right now, but it is x minus h, which in this case the h would be 4, and if it's minus, what it means is it's actually supposed to be minus, so your vertex would be 4, and then this point is supposed to be plus 5, so my vertex would be on point 4, 5, which means if I graph it, okay, my point is going to be 4 over 5 up, somewhere right about there. Now the question then becomes, is it a maximum or a minimum? Well, ladies and gentlemen, that depends on this right here and whether or not it's positive or negative. If it's a positive value, which this is, then, ladies and gentlemen, what that is it is a minimum, okay? Sorry, that's supposed to be an M. Minimum, okay? Opposite side here. Vertex equation is supposed to be x minus. Well, in this case, it's x plus. So how would this become an x plus? Is if 6 was negative. Same with this. It should be minus k, or plus k, but it's minus. So I know it is minus 4. So my vertex now, the k part, okay, hopefully you guys can understand that, the h part. My vertex here is negative 6, negative 4. But what does that mean? So if I go negative 6 over negative 4 down, my vertex will be right here. And the other thing you need to know is if it's negative, which this is, it's a maximum. So that is how you know the difference. You could graph it and get it in Desmos, but ladies and gentlemen, just know that if in fact you should know off the hand that this a value, if it's negative, it's a maximum. All right, determine the vertex of the given quadrants. This is where we kind of got off track in class a little bit, and this is how I want you to write this. So this is going to be like a little cheat. Mr. Parsons teaches this to take everything that is not associated with an x. So this would stay, but this would not, and you would move this forward to the other side, do your magic, and then you move everything back over. We're going to do everything on one side, like Mr. Olson shows down, which is one of the other teachers here. So what we're doing is we're going to put a little dash here because we don't know what number we're going to put. And it's going to be minus 4, and then we're going to place another number right here. So what number is going to go there? Well, by looking at this, most of you say, I have no idea. But if I put this bracket around it like this, isolate this as a trinomial, you guys can kind of start to see that this is almost like completing a square like we've been doing. And how do you do that? Remember, you take your b value, you divide it by 2, and then you take that value, you square it, and you'd be able to complete the square. So it's going to be a positive 9. The trick for finding a vertex without moving things to the other side would be to take this and you always subtract. So here you add the number, and then here you always subtract. Then you simplify. So if you guys don't remember how to do this, okay, it's 9 up here, 6. What two terms would multiply together to make 3? When you add them, make 6. Well, that'd be 3 and 3. So this would be x plus 3. We have 2 of them. So instead of writing it like this, okay, we have 2 of them. We just write it squared. And then it's going to be minus, and I'll put this in front. It's going to be minus 13. So there's our equation. Is it set up in vertex? If you guys look, I got some a value which we don't have because a would be 1. X minus, and then do we have it set up? We do. So what is the vertex? The vertex here, ladies and gentlemen, would be -3, -13. Okay? If I want to know if this is a maximum or minimum, this is actually a, I can spell minimum. Minimum. Alright, it's a minimum point as well. Okay, because it's the a value, which is technically is in front of here, is a positive 1. The other setup over here, let me delete this beautiful drawing. When you do this setup here, ladies and gentlemen, you get the following setup. Okay, same thing. So it'd be f of x equals x squared minus 2x plus a number, plus 5, and then another number here. So if you do the bracket around it, set your values up. So it'd be -2 on, it would be -2 divided by 2, square it, you get 1, so I'm adding 1 here, and then if I add 1 here, I gotta subtract 1 here. So you do your setup, you get x minus 1 squared. How did I do that? Factor it out, please, and then it's gonna be plus 4. So there's my answer. So my vertex is 1, 4. And the reason it's not -1, remember, because the formula is supposed to be x minus. If it is x minus, then this is a positive 1, and that's a positive 4 because that's straight down. So there you go. This also is a minimum. All right, so that's it for this side of the notes. And then we went to the next side. So we wanted to skip this one for now because we'll cover that later when we start doing the quadratic formula, which is the next lesson on 9.6. So I want you guys to solve this one out, same way. Let me do the setup, and then I will back out, and you guys try it on your own and go from there. All right, remember on this particular equation, if you do your setup correctly, you would add, so remember it's 12 divided by 2 is 6. You square it, you get 36. So it'd be 36 here and minus 36 here. So my setup would be x plus 6 squared, and then it's going to be minus 20. So my vertex would be -6, -20. And then of course, again, this is a minimum point. And then very last piece here was number 7. Okay, determine the vertex, axis of symmetry, zeros, all that great thing. So in class, we kind of walk through this one as well, but your setup would be the same. So it would go x squared minus 4x, and then it's going to be plus a number, minus 7, minus another number here. And what number is that? Would that be? So when you go through the setup, okay, make sure you do the same thing. So -4 squared or divided by 2 would be this, then square it would be 4 and 4. So minus on that one, if you set it up, do your bracket, it's going to be x minus 2 squared, and then this is going to be 7 and 4 is 11. So I know my vertex here is going to be negative, it's going to be a positive 2, but it's going to be negative 11. So let me drop it right down to here. So 2 over 11 down. So that's my vertex. My V is 2, negative 11. All right, then it asks, what is your zeros or your axis of symmetry? Well, I know my axis of symmetry is going to be the x value here. So I know if I were to graph this, I'm going to get an axis of symmetry. And oh, that was horrible. That was a horrible mark right there. Axis of symmetry is going to be, so this would be x equals 2, right? Because I know that's the line I'm on. The question then becomes, what is your value? Okay, what is the values of your zeros? And how you can do that is put everything, this whole equation, to equal 0. So if y is 0, you can solve for 0 and get your x values. Okay, so on this one, what we had done, next step, you want to isolate the x. So add 11 to both sides. Okay, when you do that, you get x minus 2 squared equals 11. Then what you want to do is take the square root of both sides. Okay, if you do the square root of this and square root of that, what happens to this? It goes away to be x minus 2 equals the square root of 11. And it's actually not square root, it's plus or minus, because we're always looking for usually 2 points. Add 2 to both sides, so your answer would be 2 plus or minus the square root of 11. If I put one of these points in a calculator, so if I know I'm going in here, 2 plus the square root of 11, I'm going to get x equals 5.32. And then if I go 2 minus the square root of 11, I get negative 1.32. So my coordinates would be 532, be somewhere right about here. And my other one's a negative 132, somewhere right there. So I know, ladies and gentlemen, let's see if I can do this. I'm not the world's most gifted artist. Not bad. The right side's a little shaky. That looks a little weird. But you guys get the drift. Okay. So one thing I want to let you guys know is sometimes you'll see this as an answer. Other times you'll see a decimal as an answer. Please be prepared to show both. Okay, that's a big key factor. That was it for this lesson. We did do a worksheet in class, but I'm not too concerned about that right now. Remember, it's all about moving and understanding what the equations are of a vertex. We're going to do transformations in lesson 9.2, so we kind of did this book out of order. And that's going to be later in the week of February 19th. I think we're going to do that lesson on the 21st of February. Okay, so that's kind of the next big key thing moving forward. If you have any questions for me, please come see me in class. Otherwise, ladies and gentlemen, have a great day, and I will see you soon.